This video covers the review for section 2.3, inverse trig functions. Find the exact value of each expression. Do not use a calculator. Inverse sine of 1. The inverse sine of 1, we're looking for the angle or the point on the unit circle in which the y value is 1. And that occurs up here at the angle pi over 2. Sine of pi over 2 is 1. I also remember this because I know that the sine, when I graph it, it is 1 at pi over 2. The inverse cosine of 1, we're looking for the ordered pair where the x value is 1. That's this one. This is 0 radians. And again, I remember this because I know the cosine wave starts off at 0, 1. Now the inverse tangent of 1, we have to remember that tangent equals sine over cosine. So we're looking for where the points have the exact x and y, where they're the same, root 2 over 2 on both of those, which makes the tangent of pi over 4 1. Remember, we know this because when graphing a tangent, we know that halfway between, which is pi over 4 right there, that's where the graph gets to 1. Now, when we start asking for the inverse sine and inverse cosine, as well as inverse tangent of negative numbers, we have to remember that the inverse sine and the inverse tangent output its angle in quadrant 4, whereas inverse cosine outputs it in quadrant 2. So the inverse sine of negative rad 3 over 2, it's going to be a negative angle. And I know that the sine of 30 is 1/2 and the sine of 60 is root 3 over 2. So it's got to be the 60 degree in quadrant 4 or negative 60. And the 60 is the pi over 3. You can't put 5 pi over 3. You have to put negative pi over 3. That's just the way they work because of the way they were defined to become one-to-one functions. The inverse cosine of negative 1/2, this will output the answer in quadrant 2. And so I know that the cosine of 30 is root 3 over 2 and the cosine of 60 is 1/2. So this is that 60 degree angle in quadrant 2. So we're looking for this angle right there, which is 2 pi over 3. Now the inverse tangent's a little bit harder because it's not on that unit circle. And again, this is going to be a negative angle, but it's going to be in quadrant 4. And so the way that I would work something out like this is I know that it's either going to be the negative 60 or negative 30 degree. And I know sine of 30 over cosine of 30, sine of 30 is 1/2, and cosine of 30 is root 3 over 2. This gives us 1 over root 3, which simplifies to root 3 over 3. So that means it is the negative 30 or the negative pi over 6. The cosine of the inverse sine of root 2 over 2. We're first asked for the inverse sine of root 2 over 2. We know that happens at pi over 4. So then the cosine of pi over 4 is, well, cosine of pi over 4 is root 2 over 2. We're right back at root 2 over 2. Inverse cosine of 0 again. We're looking for the x value that's 0. That's going to be at pi over 2. And then the sine of pi over 2 is the y value there at pi over 2. That's equal to 1. Tangent of inverse sine of negative 1/2. Inverse sine of negative 1/2. We know the sine of 30 is 1/2. And so but it's a negative 1/2. So we're down there at negative pi over 6. The tangent of negative pi over 6, well, I think of this as sine of negative pi over 6 first, and then cosine of negative pi over 6. Well, we just did sine of negative pi over 6. We did it backward a bit ago, just the inverse sine of negative 1/2, so it brings us back to negative 1/2. And the cosine of negative pi over 6, in quadrant 4, cosine's positive, and pi over 6 being a 30-degree angle, this is root 3 over 2, which gives us negative 1 over root 3. And when we rationalize the denominator, we get negative rad 3 over 3. Tangent of inverse cosine of negative root 3 over 2. Inverse cosine of negative root 3 over 2. I know that the cosine of 30 degrees is my root 3 over 2. But that's in quadrant 2 because it's the inverse cosine negative. So it's this one right here, the 5 pi over 6. Tangent 5 pi over 6 is sine of 5 pi over 6 first. Sine is positive in quadrant 2, and that's of a 30-degree angle, so that's 1/2. And then the bottom is the cosine of the 30 degrees in quadrant 2, which is negative rad 3 over 2. This one also simplifies to negative 1 over rad 3 or negative rad 3 over 3. Cosecant of inverse tangent rad 3 over 3. Inverse tangent of root 3 over 3, that's a positive angle. And I've seen that that happens at the 30-degree angle from these last two exercises. So this is at pi over 6. Tangent pi over 6 is root 3 over 3. And then the cosecant of pi over 6, well, that's 1 over the sine of pi over 6, or in this case, 30 degrees. Sine of 30 is 1/2. And this gives us 2. Now 23, it says the cosine of inverse tangent of 3/4. 3/4 is not a ratio that I've seen on my unit circle or something that I've memorized. So I have to go back and remember what the inverse tangent of 3 over 4 means. It's an angle whose tangent is 3/4. Opposite over adjacent, which makes the hypotenuse 5 because it's a 3, 4, 5 right triangle. And now we're just asking, what is the cosine of that angle? Well, that's adjacent over the hypotenuse. Similar in number 24, this is the angle inverse cosine of 3/5. This is the angle theta, whose cosine is 3/5. And that's also a 3, 4, 5 right triangle. And then the sine of that angle is 4/5. Now, 25, inverse sine of negative 3/5. Remember, the inverse sine of a negative number comes from quadrant 4. So when I draw this triangle, I have to draw it like I'm in quadrant 4. And remember that this is a negative y value. R is always positive. In this case, the x is positive in quadrant 4. So now we're asking for the tangent of that angle, and that's opposite over adjacent. The next one, you've got an inverse cosine of negative 4/5. Inverse cosine is an angle in quadrant 2, and that's negative 4/5, adjacent over hypotenuse. And this is again a 3, 4, 5 right triangle. And then now we're just taking the tangent of that angle. The tangent of that angle is opposite over adjacent, giving us negative 3/4. Last one of this kind, sine of inverse tangent of negative 1/3. If theta is inverse tangent of negative 1/3, then theta is the angle whose tangent, which is opposite over adjacent. However, because it's negative, I have to remember that I'm in quadrant 4. And if it's opposite over adjacent, I have to put the negative on the 1. Now, a squared plus b squared equals c squared. So that's 9 plus 1 is 10. That's the square root of 10. We're taking the sine of that angle, and the sine of theta is negative 1/√10. We rationalize the denominator on that and get negative √10/10. All right, these last three, inverse sine of the sine pi/3, and then inverse sine of sine 2 pi/3, sine inverse cosine 2 pi/3. The sine, there's two ways to do this. You think, okay, inverse sine and a sine, they undo each other, and you just end up with pi/3. But the problem is this one doesn't equal 2 pi/3. So you got to be a little bit more careful here. Sine of pi/3 is the sine of 60, which is √3/2. And then when I ask you for the inverse sine of √3/2, it just brings me right back to pi/3. The sine of 2 pi/3, that's 60 degrees in quadrant 2, and the sine is positive there, and the sine of 60 is √3/2. But remember, we just said the inverse sine of √3/2 is pi/3, not 2 pi/3. So you got to be careful with these. Number 30, we've got cosine of 2 pi/3. The cosine of 2 pi/3, that's a 60-degree reference angle, and cosine of 60 is 1/2. But in quadrant 2, where 2 pi/3 is, it is negative 1/2. And then the inverse sine of a 1/2 would be a 30-degree or a pi over 6 angle, but because it's negative, this is negative pi over 6. All right. Use a right triangle to write each expression as an algebraic expression. Assume that x is positive and that the given inverse trigonometric function is defined for the expression in x. All right, so these problems are similar to the problems up here where I kept drawing diagrams, but they just have variables in them now. So we let theta equal the expression inside. So the angle theta is such that the tangent of that angle is x over 2. That's opposite over adjacent, tangent's opposite over adjacent, which means that this is the square root of x squared plus 4. Now, you got to leave that thing as the square root of x plus 4. There's nothing we can do to make that look any nicer. That's just what it is. So then the cosine of that angle theta is adjacent over the hypotenuse, square root of x squared plus 4. Yeah, we got to rationalize the denominator, which gives us 2 square root of x squared plus 4 divided by x squared plus 4. That's what we mean by to write each expression as an algebraic expression. So we start with a trig expression, now it's an algebraic expression. 32, we let theta equal the inverse sine of 1 over x, and that means that the sine of theta is 1 over x. So we draw a triangle in which the angle theta has a sine that is 1, all divided by x. We use the Pythagorean theorem to find the unknown side there. A squared plus b squared is c squared. That says that a squared is x squared minus 1, or a is the square root of x squared minus 1. So the secant of that angle is 1 over the cosine, and the cosine of that angle is square root x squared minus 1 over x. So it's going to be flipped, x over the square root of x squared minus 1. So we rationalize the denominator and get x square root x squared minus 1 divided by x squared minus 1. And this concludes the video for the review exercises for section 2.3.